You can use any type of protocol to transfer this data, but you will study the protocols that you use to format the data and send to the server. This protocol is in the application layer, is not in the, it's a little up layer in the transport protocol that you studied in the last session. Okay, so give me a second, I'm sharing my screen. The topic is this topic here, okay, is 6.45. Is the last stop before the next week is the Semana Tech, no? But it's the last stop to discuss this week. And we have an activity here. So today we study data transfer protocol used by IoT. You already discussed, give me a second. Okay. We already discussed about what is protocol. Remember, what is a protocol is a set of rules that define how a communication happens. Until now, you studied the low-level protocols like Wi-Fi that define in details, the bits by bits, how you send the data, how to insert the data, how to transform the data to be possible to insert in the wireless channel. Okay. Today, you study a little app protocol, the protocol that defines, for example, the confirmation that your message sent is not. You discuss about more high-level protocols. I reinforce it because it's important. Okay. You have a complete course about it in the next year. Okay. But to understand how the protocol works, you define the protocol functions in layers. Okay. For example, one important task that you need to have to transfer data to other is how to insert the data in the chain. For example, how to transform the data in electric sign to insert in the electric cable, or how to transform the data to insert in to transform this data in the electromagnetic pulse to send in the wireless channel. It's one thing that you need to do. Another one is how to define the path that the data you send, you navigate from the source to the target. Okay, there are a lot of functions that you need to have to establish one communication. Okay, and in the beginning of the network, you don't have this division. Okay, you don't divide the task by layers. The consequence is, if you buy, for example, a computer from a provider, you need to buy the computer, the cables, the routers, any device that you need to use to communicate one device to other. You need to buy from the same provider, because the provider is responsible to perform all the tasks. But the ISO or OSI start to think, oh, it's not a bad idea to break the task in small parts, and one provider can provide only the functionality to insert the data in the channel. Another can provide only the functionality related to the routing message. Another, how to handle this information, this data in the application, for example, in WhatsApp, in Google and others. Okay, it's what means it's what's in the OS model. The OS model is an open system interconnection model. It's a concept framework used to describe the function in the network system. For example, you have the bit layer that responds to media silent binary transmission, okay, to transform the data to insert in the cable. You have the data link. The data link is responsible to manage, for example, when people use the channel, when the other use the channel. The network is responsible to define the path that the data you join. What is the path that the data will pass from the originator to target? You have the transport layer that is responsible, for example, to define that the communication is reliable or not reliable. For example, if there is type of the transport protocol that's reliable. For example, you send a message and you wait to receive, oh, I received the message. There are others that is unreliable. For example, you send the data and send the next, and send the next, and send the next. You don't wait for any confirmation. Okay? It is what the OS model defines. It defines the network task in the specific layers, or it divides the network task in the small tasks. Any questions? Okay.
Not for now.
This video explains exactly what means the OS model. It's a very nice video. There are a lot of animation that is easy to understand, okay? Pay attention.
Welcome to Cert Bros. In this video, we're going to be taking a look at the OSI model. So, what is the OSI model? The model is a theoretical stack of 7 layers that can be used as a reference to help understand how networks operate. The model was introduced to standardize networks in a way that allowed multi-vendor systems. Prior to this, you would only be able to have a one-vendor network because the devices from one vendor couldn't communicate with others. It's worth noting at this point that we don't actually use the OSI model. We use something called the TCP/IP model. The concepts are exactly the same, the layers are slightly different. So if we don't use the OSI model, why would we bother learning it? Well, that's because it's still referenced a lot when troubleshooting or describing network operations. Let's take a look at the layers starting from the bottom up. Layer 1 is the physical layer. The physical layer is the lowest layer of the OSI model. Its key responsibility is to carry the data across physical hardware such as Ethernet cables. Layer 2 is the data link layer. At this layer, the physical addresses are added to the data. This is the source and destination MAC addresses. Switches are located at this layer. The network layer handles IP addressing and routing. At this stage of the OSI model, the source and destination IP address are added. Routers operate on this layer. Layer 4, the transport. The transport layer of the OSI model adds the transport protocols such as TCP and UDP. TCP, for example, is used for error handling and sequencing to ensure no data is lost. This layer also adds the source and destination port numbers. Layer 5, session. This layer is responsible for establishing and terminating connections between devices. Layer 6, presentation. This layer formats the data in a way the receiving application can understand it. This layer is also able to encrypt and decrypt data if needed. Layer 7, application. This layer is where the application and user communicates. Application-specific protocols are used here, such as SMTP, if you're sending an email, for example. A really good way to remember these layers is simply all people seem to need data processing. APS-TNDP. So to fully understand how this model works, you need to see a real-world example. Let's say you send an email. The data travels through the OSI model, adding and processing data on each layer. Now this process is called encapsulation. Step 1, the application layer. Outlook creates the data, the email you wrote, the email addresses, etc., etc., and gets ready to send it using SMTP, which is the Simple Mail Transfer Protocol. Step 2, presentation layer. The data is formatted in a way the receiving device will understand. In this example, probably ASCII. This layer could also encrypt the data if needed. Step 3, session layer. A session with a receiving mail server is started. Step 4, transport. This is where it decides to use TCP or UDP. In this case, we'll use TCP to make sure every packet gets delivered. Also, the source and destination port is added to the data. Step 5, network. The IP address of the mail server is added as the destination, and the source IP address is also added to the data. Step 6, data link. The MAC address of the router and the source MAC address of the host is added to the data. Step 7, physical. The data is sent out on the network using Ethernet. So when the data reaches the other side, the receiving device will process the data in the same way but in reverse, starting from the bottom up. Okay, so that's the OSI model, but how can we use this to troubleshoot? You may have heard the term, oh, that's a layer 2 problem, or sounds like a layer 3 issue. When you hear that, that's people referring to this model. Let's say there's a problem with the network. If we go through this model, checking every layer, we can soon diagnose the problem. For example, layer 1, are all the cables plugged in? Is the network card functioning? Could it be a fault with cable? Layer 2, maybe the switch has gone bad. Layer 3, is the router functioning? Do I have the right IP address? And the process goes on and on from there. I hope you've enjoyed this video. If you have, remember to subscribe, comment, and give a thumbs up.
Okay, did you understand what the guy explained?
Yes. Yes, teacher.
Okay, it's really nice because, for example, today, until now, when we study the wireless protocol, we study this part here, okay? It's here that you define, for example, the Wi-Fi, the LoRa, the NB IoT, and others, okay? And all of this protocol need, for example, IP. IP is defined in this layer, okay? It is the IP. Today, we start to study protocols that is defined above, okay? And the first protocol is the transport layer, okay? Where you define end-to-end communications and reliability. So, the first protocol that we study is the transport. It's responsible for logic communication between applications running on different hosts. For example, when you send one packet from my machine to your machine, I don't know which path this package you navigate until you arrive in your computer. I don't know. For example, the first package can go to the path 1, the second path can go to the path 2. The transport layer defines a logical connection between my computer and your computer. Okay, it's don't matter the path. It's what's the name is abstract. For example, it abstracts the path. Again, it creates a logical communication between my computer and your computer. Okay, and there are one server that this layer define. For example, if you are reliability communication and unreliability communication. Okay, in this layer, you have in the TCP/IP, you have two protocols. The TCP, when you want to have a reliable, and the UDP, when you don't want to be reliable, you want to be unreliable communication. And the TCP, again, it's a reliable delivery. You establish a session, okay? How it works? Fix that you are the sender and it is the receiver. When you send the data to the receiver needs to send, oh, I received the package, okay? Like in this example here, you send the data and the receiver say, okay, I received the message, send an ACK. Send the data, okay, you send a new ACK, okay? The TCP assure that you, for example, if you lost any package, for example, if you send this data here and didn't receive this ACK, you need to send the data again. Why? Because you didn't receive the confirmation that this guy received the message. Okay? And the TCP, you assure that the guy received the message. You have another service that this protocol provides, the same order delivery. It's not only to receive the data. You need to receive the data in the correct way. Okay? Things that, for example, things that you have node A, node B, okay? And you send the message 1. As you're told, if you use TCP, you need to receive the SK 1, okay? You send the message 2. You need to receive the SK 2. Did you understand until here? Yes?
Yes.
Okay. Okay, but fit the situation. You send the message 1 and didn't receive the message 1. You stop? No. You define a timeout. Okay, when you start the send of data 1, you start a timeout on clock here. Okay, if you didn't receive any confirmation during the timeout, you send the package 1 again. Okay, and you send again until when? Until you receive the escape. Okay.
Just one question.
Okay.
For example, is there a limit of messages sent when there is a timeout waiting, or there is no limit?
Yes, there is a limit. There are another thing that we will explain now that to avoid, because if you use this approach, your communication is very bad because, for example, you send a package, receive a message. You send a package, receive a message. You send a package, don't receive nothing. Send again the package, receive a message. It's a very no performatic protocol. You have support to flow control in the TCP. I explain now, okay? So, second, share again, okay. The problem of this approach is if you did, you create a congestion in your channel because you need to send one SK to each data that you send. It's a problem. To avoid the situation, you have support flow control. You can send, for example, you define a window, okay? Think that in this case, 1, 2, 3, 4. The window is equal 4. You can send the message 1, 2, 3, and 4, okay? And the receiver, what receiver you answer? The receiver, you answer ACK4. What means ACK4? It means that you receive the package 1, the package 2, the package 3, and the package 4. Okay. But think the situation. You didn't receive the package 4. You received the package 1, 2, and 3. You send the ACK3. What it means? It means that you receive the package 1, the package 2, package 3. But you didn't receive the package 4. In this case, what the sender you send? You send the package 4, 5, 6, 7 until 8. Did you understand?
Yes.
Okay. It's the way that you control to avoid to be a lot of retransmission message. But fix another problem. You send the package 1, 2, 3, 4, 5, some 5, okay? Windows is 5. Okay, 1, 2, 3, 4, 5. You didn't receive the package 3. What happened? Which ACK will send? ACK4? What do you think? Come on, guys.
Yeah, 4 or yeah, 4, no?
No, why? Because if you send the ACK4, it means that you receive the package 1, 2, 3, 4. But you didn't receive the package 3. In this case, you need to send ACK2. Okay, because you received the 1 and 2. What happens? What happens that this guy will send the 3, 3, yes. 3, 4, 5, 6, 7, and 8. No, and 7. Okay? Because you didn't receive the package 3. You lost the package 3. So you need to send the ACK2. So what informed the ACK2? Oh, the guy received the 1 and 2. The 3 and the others, I don't know. The 3 didn't receive, and the others, I don't know. So I need to send again the 3, the 4, the 5, 6, 7, using the window. Did you understand? Yes or no?
No.
Okay, I repeat. I try to use the... Okay. The window is, for example, 4, okay? And it means that you send the package 1, the package 2, the package 3, and the package 4, okay? However, for any reason, you lost the package, the package 3, okay? You didn't receive the package 3, okay? You received the 1, received the 2, the 3 no, and the 4, okay? Because you lost the package 3. You lost the package 3. Because it's a protocol, no? You cannot say, oh, I receive 1, 2, and 4. You say ACK2. What means ACK2? I receive until the package 2. Don't matter what you receive after. If I lost the package 3, don't matter what the others. Did you understand now?
Yeah, thank you. It's clear.
Okay, and what happens? Now, my type, I will send the package 3, the package 4, the package 5, and the package 6. Okay? 3, 4, 5, 6. If I receive all the package, my ACK will be ACK 6. Do you understand now?
Okay, okay. Yeah.
Okay. If I lost one, I send until the package that we receive. Okay. It's the three services that the TCP provides. Things like the TCP. Stop here and share. Okay. Things a TCP like it's a this example is very easy in the past, but you don't have now. For example, when you send one email, okay, I don't know if you have this experience. If you use Outlook, for example, Microsoft Outlook to send a mail, you can mark the message to receive a confirmation that the destination received the mail. Okay, it's like, for example, when you send a letter and you put RSVP, no? In some letters, for example, to invitation to parties, important parties, or events, you can use this symbol, this letter, RSVP. What it means? It means that when you receive an invitation and it has RSVP, you need to call back and say, oh, I will go, or I don't go. Okay? Your confirmation. I received the message and I will go. Or I didn't receive, or if you didn't receive any message, any answer is because the guy don't receive the message. Did you understand?
Yes.
The problem of this protocol is that it's not performed very well because, for example, I don't know if maybe you already see in the internet some videos or some memes that explain, for example, we receive some paragraph, okay, of text, and the guy missing some words, okay? For example, like Andre, achievement, sorry. The car is blue and it is on the street. The car has a driver. Okay, I believe you already see some examples like that. And when you read this message, if you have part of information that you lost, you don't have, for example, here I miss the A, here I miss the I. Yes. If you read this sentence, you can understand because our brain can complement the missing information. Okay. If you have know a lot, okay? For example, if you have only this part, you don't know what this guy wants you to say. But if you have only few parts of the information that is lost, your brain can reconstruct or can build the information. Okay, it's a capacity that you have. So it's the same in voice. Okay, what is the worst? If your brain has capacity to rebuild the information, instead you have a lot parts of information that you don't have. Sometimes it's a good idea to do not provide this reliability, okay? For example, in the voice and the video. Think about the YouTube. Sometimes you have the video jump to another part and you don't lose a lot of information. You can continue to watch the video. You lost, yes, but it's not so bad. You can continue to watch the video, the move and video, and can comprehend what is the message, okay? In this type of application, you don't use the transport control protocol. You don't use TCP. You use another one that is the Wi-Fi, is the UDP, okay? The UDP is the user datagram protocol. Is a connectionless communication protocol located in the transport layer. While the TCP, you send a message, okay, and you inform when you didn't, you say, oh, the data is corrupted, please resend. In the UDP, no all data is present. To do nothing. I can't handle this problem, okay? It's something like, for example, in the TCP, you send the data is corrupted, you send the ACK, you send, oh, the data is correct, or I need to retransmit the data in the TCP. In the UDP, no. In the TCP, you send the data, if the guy receives, if the data is correct or not correct, it don't matter. It don't matter. You go ahead and when you use UDP, you consider that the application can handle the error, or the error, to handle the error is worse than to to have the error. Did you understand? For example, the UDP you use in the VoIP and multimedia stream in real time in the multimedia applications, okay? Did you understand the difference?
Yes.
For example, it's a joke. The TCP, you send the kids and you assure that the receiver has condition to receive the data or receive the package. In this case, it's the kid. In the UDP, you send. If you have the receiver is ready to receive, it's another problem. It's not your problem, okay? Again, TCP is connection-oriented protocol, okay? The path set up before the data is sent. In the TCP, you have one thing that the name is the handshake. What is the handshake? The three-way handshake. Before you can send any data, you have a communication between the two parts, the receiver and the transmitter, and that's it. The sender say, oh, I want to talk with you. And you say, oh, I'm ready. And the receiver and the sender say, okay, I'm ready. After you have this three handshake, you start your talk, okay? UDP don't have this step. Oh, I need to send data to the destination, send, and so on, okay? And the TCP, the path setup is, the path is set before the data is sent, okay? For example, the telephone system. It's not true today. It's things that happens in the past. Okay, today a lot of telephone systems use the packet data. It uses sometimes of the TCP, but it's not a real true. And the HTTP connectionless protocol. You don't define the path. You send the data. It's like the postal system. For example, I don't know if one of you use letters to send. It's very common, for example, in the Christmas in the United States, to send letters to your family, to your friends, and to your business partner. I don't know in the mass community, it's not common. It's not, the people don't do it not anymore. But in the US, yes, I receive every year a letter from my friends in the US and from the university in the US that I work, that I study, but it's not a common practice in Brazil. I don't know. In the Mexico, do you send letters, physical letters in the Christmas? to your friends or to your business partner or not in Mexico?
Very rarely, almost basically no.
Yes, it's like in Brazil. In the West, it's very common. It's nice. Yes, nice. What? It's nice because there is a very, very beautiful letter. It's a thing that is amazing. They're like in the West. There are a lot of things that you don't like in the West, but these things are like. And you use the postal system. When you send a letter, for example, using the postal system, you don't have any control with the destination receipt. You can say, oh, in Brazil, we have, for example, one service that you receive a confirmation that the guy received the message in the other side. But the common behavior, not the special service, the common service. In the common service, you send the letter and don't receive nothing. Okay? You don't receive any feedback. You don't receive any confirmation that the destination received the letter. Okay? It's how the UDP works. Okay? The TCP is slower but reliable. The UDP is fast, but no guarantee is best for, no, it's no guarantee transfer. Typical applications, email, web browsing, and typical application, the VoIP music stream. About unicast, multicast, we don't talk about it today, okay? So again, during the course, the network course, you study again in detail. We implement this protocol. You use the Cisco routers to implement these protocols. Okay, the idea here is only to have a big view. So the important information that I would like to memorize, that you memorize, is TCP. You send a message, receive the confirmation. UDP, you only send the message. A good picture to memorize is this one, okay? This one is nice. TCP, the sender ensure that the receiver is read and receive the package. In UDP, you only send. Don't matter if the guy received, it is done, if it's read or if it's not read, it's not your problem, okay? Any questions? Okay, when you see the IoT protocols in the ISO stack, again, as I told you before, the 6LoWPAN, wireless, Wi-Fi, 3GPP. The 3GPP is the 4G, 5G, and IoT, Edge, okay? This protocol is in data link and the physical layer. In the network layer, you have the IP, okay? IPv4 and IPv6, okay? And the transport, you have the TCP and TCP/UDP. And today, you study this layer here, the application layer, okay? IoT protocols in the application layer. You have, we study 3 protocols here. The QoAP, okay, is the constraint application protocol. The message queue telemetry, MQTT, it's the protocol that we implement, that we use in the last lab. And the advanced message queue protocol, MQP. The DDS is, you don't study this in this part. The first is the constraint application protocol, the QoAP. The QoAP is an internet utility protocol for restricted gags, okay? You use this protocol only in very, very, very restricted gags, okay? Today, it's not so common to use, okay? But we use in the past. The protocols use the HTTP to transport the data. Do you know what is HTTP? Who does not know what is HTTP?
No recuerdo, pero solamente sé que si es HTTPS es por sistema extra que le da seguridad, pero no sé qué sea HTTP en sí.
Yes, HTTP, it's a protocol that you use, for example, is a protocol in application layer that you use to transform data and use the browser, okay? For example, if you use HTTPS, it's secure. If you don't use HTTPS, it's not secure, okay? For example, here, I don't know if you see here, you use HTTPS and website. What this protocol does, when a web server receives this message, it get this query and return with the content that is this page here, okay? When you receive, HTTPS is a client server, okay? You have a client, is your browser, and you have a server that is a web server, okay? When you send, for example, you type HTTPS, experiência 121, TechMX, blah, blah, blah. When you type it, in the web server receive this message, it's looking for in the file system, the file, in particular the models, that represent, that has the content that this guy asked, okay? For example, HTTP GET, okay? When you send the GET, you go to the web server, receive this message and say, oh, what is the content that this guy wants? Ah, the content is this page, and return with an HTML page. Did you understand? Yes or no, guys?
Yes.
Okay. So when you use HTTPS, it means that you establish a connection, secure connection, before you send the data. Okay, HTTP does not have security. HTTPS, you have security. Okay. So the co-op use HTTP protocols. Okay. It use a protocol that's the name is the RESTful. Okay. It's RESTful. It's like HTTP. The difference between the RESTful and the HTTP is that the RESTful is define a way that you interpret what the REST will do. But first, REST is an architecture style. Okay, it's a design pattern. It's an API. We use the REST to represent information. Okay, when you use the REST API, it means that you send an HTTP message like a GET that I showed, and the output will be a JSON file or XML file. And when you use HTTP pure, the only HTTP, you send a GET, POST, PUT, delete, and receive a HTML page. Okay. If you have a REST here, okay, you receive a JSON or XML. Okay. A JSON is a format that you can use to store things in the database. Okay. I believe Jose Maria told about it with you. Any questions?
Nope.
When you use the code, what you have? Things that you have the device here, okay, the co-op clients, okay? And you need to have a co-op server, okay? But this co-op server, it's running only locally. You cannot use, this server cannot be in the internet, okay? To be in the internet, you need to have one proxy that translates the co-op message to HTTP. What it means? It means that if you have a co-op environment, you have a server, you have the clients, client 1, client 2, client 3, that you use co-op message to send message to the co-op server. But think that you have one resource that is here in the internet, okay? This resource need to send the data to the REST co-op proxy that translates and send to the co-op server, okay? It means that the co-op message does not it's not encapsulated in the HTTP. Again, the co-op environment you use only in the legacy implementation, in the old implementation. It's not so common today. Today, you'll be the MQTT. The MQTT means MQ, message queue, telemetry, transport protocol. It's a very, very lightweight message protocol designed to high latency, low bandwidth, and reliable networks. Okay. This protocol consumes very little power on the device. If you remember, you send like a string when you send your temperature, for example. In the example that you used in the previous example, exercise, you send very light, you send the one string that you send, temperature and the value, okay? You don't send a lot of things. You send very, very simplistic things. Using this protocol, you can send more data, for example, using JSON, but you don't use, until now, the JSON message to send message to one node to other. It's very simple, okay? You have a publish, you have a subscriber, and you have a top. What it means? The publish send data to the top, and the top and the subscriber go to the top and read all the message that you have there. One practical example. You have a publish that send, for example, the temperature, the humidity, if the light is on or off. You have one entity that is MQTT broker. What is the broker? The broker is like a server that receives all the messages that the publish. For example, in our case, you publish only the temperature, okay? And the broker, okay. Who works like a broker in the example that you worked in the last session? Who is the broker in the Microsoft Cloud implementation?
¿Podría repetir la pregunta?
Sí. Who? Okay. When in the last lab, okay, in the last lab, who is the broker? MQTT broker. You publish, you create a publish using Python. Am I correct? And this publish send data to one place. Who received the data in the cloud?
Well, it was the thing that we created regarding the hub of Azure.
Yes, the hub, the Microsoft hub, okay, is our broker. Did you remember in the second exercise, the hub received all the message from the Python code and send this data to be handled inside the cloud. Did you remember?
Yes.
Okay. The Microsoft Hub is in the last exercise is our broker, okay? And we'll have a Python code, okay, that they publish the temperature. You send this data to the broker, and if you remember, you have another Python code that is the subscriber, okay? Is the computer that receives this message, okay? In our example, you have the Microsoft Hub here, works like a broker. I cannot remember the name of the Python code, okay? But you have a Python code that send the temperatures, if I don't wrong. And you have another Python code that reads what you publish. Did you remember? Do you remember? Give me a second. Okay. It's the exercise. No, you send the data. Or did you see what you do? You create the connection. You connect the broker, that is the hub, and send the temperature. Okay, you send the temperature. Send data by data. Send data by data. Okay. It's what you did in exercise 6.4. It is one. Okay? Any questions?
No, for now, teacher.
You have some features, okay? The first is the quality of service levels, okay? And the quality of service define a SIM agreement between the sender and receiver, okay? And it's defined, for example, how many messages you can receive when you send some SKs and other things like that. You can persist the session. You have the last will. The last will is a message that you can send to the broker and you disconnect aggressively. It's like, for example, you have a publisher that you don't send the disconnect. You only, I will go, okay? It's the last will. And this protocol works well on reliable networks, okay? Oh, my slides. Today, you study in detail the MQTT, okay? You study the MQTT, you implement a network using the MQTT, okay? Another protocol is the Advanced Master Queue protocol. This protocol is a little advanced. The most common protocol is the MQTT. The AMQP is not so, how I say, it's not so, it's very powerful, it's new, but you don't have a lot of implementation. This protocol has the best solution, for example, to security, okay? And it has the point-to-point and publish-subscribe. It has not, all the other protocol use the publish-subscribe. You have a publish and you have subscribe, okay? Like you see here, you have a publishers and you have subscriber. The AMQP support the publisher and subscriber, but support point-to-point too, okay? For example, if you use MQP, you have the MQP broker. In the MQP broker, you have multiple publisher and you support queues, okay? And the subscriber do not access directly the broker, it access the queues. The advantage to it is because you can have, for example, you can implement the broker, you can clusterize the brokers, okay? You can have multiple brokers that support the same status, okay? Again, you have support to MQP, for example, in the Microsoft, but it's very expensive to use this protocol. When you compare the protocols, the co-op is implemented by IETF. IETF is the organization that implements all the protocols in the internet. For example, the TCP/IP is defined by the IETF. The MQP is provided for OASIS and the ISO. MQP, OASIS, for example, has a lot of standards in the, not only in the internet, but it's more related to the applications. And the ISO is you have the ISO model, okay? And the IMQTT is from the OASIS. The co-op use the request response, remember the HTTP, MQP and MQTT using the TCP. The co-op has very simplistic standard to security. The MQP and the MQTT has more strong security, and all of them support the QoS. Again, when you analyze these protocols, MQP, for example, the co-op supports UDP only, and the scope is device to device, okay? You use the co-op only device to device, okay? But when you think to use cloud, you need to use MQP and MQTT, okay? The important things here, okay, is the things that make the MQTT the most useful, the most common protocol is because you can use the broker as a service, okay? And the MQTT is a very inexpensive protocol, different than MQP, okay? Any question, guys?
What is SPO? In the broker is the SP. What is SPO? In the broker is the SPO.
Where do you read it?
What the meaning the letters SPO in the MQTT? See, yes.
What it means? Give me a second. I believe it's the correct means, no? SPOF. Oops. SPOF. Give me a second. Okay. It means the single point of fail. Okay, SPOF. And it means that if the broker failed, you lost the MQTT network. Okay, and MQP, you don't have this problem because you implement queues and you can clusterize the brokers. You know what is clusterize? What means this term?
Yes, now I understand what means.
Okay. So guys, okay, this session, the first session is only an introduction of the broker, okay, about the MQTT, the protocols, and the all. In the next session, after the break, we will do one exercise, a hands-on exercise, where we use, you create a machine in the cloud, okay, and we use one application. The name is Mosquito, Eclipse on Mosquito. That is an MQTT broker. Okay, you install this Mosquito in the Linux. You configure the Mosquito. You see that it's very easy, and you create an application in Python to work like a subscriber and to work like a publisher. Okay, we'll do it after the break. Until the break, before the break, any questions?
No.
Okay, guys. We return 10, 12, okay? 10 minutes break, okay? See you soon, guys.